Okay, in this video, we're going to be multiplying and dividing complex numbers, which we actually have already done. However, we're going to multiply and divide them in trig form. And that's what we're going to be looking at here. Given a complex number, z1, that's in that trig form, and z2, which is also in the trig form. The product and quotients of z1 are given by the following formulas. Now, this might not be faster right now. However, when we start raising complex numbers to powers and doing things like that, it will speed up the process. So we got to start somewhere. So let's go ahead. The product formula. If you're going to multiply z1 times z2, here's how you do it. You simply first do r1 times r2. Let me zoom in just a little bit. So you're going to multiply your modulus 1 times modulus 2, and then you're going to do the cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2. So you're going to multiply the modulus, the two moduli, I guess you could say, and then you're going to add your angles, and that's it, to multiply two complex numbers. So if that's what you do when you multiply, then to divide, you're going to do something very similar. You're going to divide the two moduli, and then you're going to take the two angles or the arguments and subtract them. So not Q, but theta 1 minus theta 2, and then plus I sine theta 1 minus theta 2, and that's it. So let's do some examples. It says find each product. So to multiply, and these are in trig form, you're simply going to take the modulus, and you're going to multiply the two, so you get 12, times the cosine of, you're going to take your two angles, 5 pi over 4 and pi over 2. Let's come over here, and you're going to simply add them. You do need a common denominator. Let's multiply top and bottom by 2, and that gives you 2 pi over 4. So when you add them, you get the cosine, and let me do some brackets here, the cosine of 7 pi over 4 plus I sine, same angle, 7 pi over 4, and that's it. Now that does not look like a complex number, so what we're going to do, we're going to take this trig form, and let's go ahead and remind you, and let's change this thing back into rectangular form, which I keep calling trig form, or excuse me, standard form. So 7 pi over 4, pi over 4 is 45, so that's 315 degrees, each of those angles is. So I've got to find the cosine and sine of 315. 315 is in the fourth quadrant. Your reference angle is 45. So therefore, our cosine will be positive. I'm going to go ahead and put a positive right there. The cosine of then your reference angle, which is 45 degrees, is root 2 over 2, plus I sine of the exact same angle. Now that would be a negative because it's in the fourth quadrant. All students take calculus. And the sine of your reference angle will also be root 2 over 2. So you can change this here. You have a positive times a negative, so you can just put a minus right there instead. And now let's simply distribute. 12 times root 2 over 2 will be 6 root 2, minus the exact same thing, 12 times root 2 over 2 will also be 6 root 2, and you can put the I over here. Most of the time, we'll write that as 6I root 2, just so we don't get that I under the radical. Number 2, again, we're multiplying these together, so take the 5 and the 2 out front and simply multiply those two moduli. 5 times 2 is 10. And then you have the cosine of, take your two angles, which is 11 pi over 6 and 2 pi over 3, and you simply add them. So that'll be 11 pi over 6 plus, common denominator will be a 6, so multiply top and bottom by 2. And that gives you a 15 pi over 6 when you add them, plus I sine of the exact same angle, 15 pi over 6. Now 15 pi over 6, I should have reduced that. Divide top and bottom by, let's see, 3, and you get 5 pi over 2. And 5 pi over 2. 5 pi over 2, let's change that to a degree so it's easier to work with. That's going to be 450 degrees. However, if you take a rotation away, you have a 90-degree angle. So that's simply the cosine and sine of 90 degrees. So that'd be 10 times the cosine of 90 will be 0, plus I sine of 90, which will be times 1. So that's going to be 10 times 0 is 0. Actually, you can do away with that. 10 times 1i will be simply 10i. Okay, starting with number 3, we're now dividing. Now to divide, instead of multiplying the two numbers out front, you simply divide the two numbers. So you have 2 divided by 4. Then you have the cosine of. Instead of adding the two angles, you'll subtract them. So you're going to do pi over 2 minus pi over 3. Common denominator would be 6, so this would be 3 pi over 6 minus 2 pi over 6, which is 1 pi over 6. And if you would like to go ahead and write that in as a 30-degree angle, you can. So cosine 30 plus I sine 30. And again, we simply subtracted those two angles. Now let's clean that up. You have a 1/2 out front. The cosine of a 30-degree angle, these are both in the first quadrant, so everything's positive. The cosine of 30 will be root 3 over 2, plus the sine of 30 will be 1/2. So there's what you now have. Distributive property, that'll be root 3 over 4 plus 1/4 I, and that is now in complex form. And let's do one more of those. Again, take the two numbers to divide these two complex numbers. Take the two numbers out front and divide them, and we will have to rationalize that. And you will simply take your two angles, 7 pi over 4 and pi over 2, and subtract them. 7 pi over 4 minus pi over 2. I'm going to go ahead and multiply top and bottom by 2 to give me a common denominator, and you have 5 pi over 4. But again, I would much rather work with degrees. So pi over 4 is 45. That's 5 45s, which is a 225-degree angle. So there is the rest of it. Now let's clean it up. 225 is in the third quadrant. All students take calculus, so both cosine and sine will be negative. Let's go ahead and rationalize this out front. Multiply top and bottom by root 2 gives you 6 root 2 over 2. 6 and 2 reduce, and that will be a 3 root 2. The cosine of 225, again, will be negative. Your reference angle is a 45-degree reference angle. The cosine of 45 is root 2 over 2. Since this is negative, I'm going to put a minus here instead of putting the plus and negative. The sine of a 45-degree angle will be the exact same, root 2 over 2. We now have to distribute the 3 root 2. 3 root 2 times root 2, this is over 1. 3 root 2 times root 2 will be 3 times 2, which will be a negative 6 over, and then you got a 2 on bottom. And you're going to get the exact same thing when you multiply the second one. It'll also be 6 over 2 with the I, and we know that 6 over 2 will be negative 3. So you have negative 3 minus 3i, and there is your complex number. Okay, now we can go a step further. We can now raise these complex numbers now to powers by using de Moivre's theorem. Abraham de Moivre is credited with discovering a useful pattern for evaluating powers of complex numbers. Given complex number z, which is r times cosine theta plus I sine theta, that's our trig form, de Moivre's theorem for z to the nth power is the exact same thing we just did. Z to the nth power, well, how do you multiply these things together? Well, you multiplied first off, your modulus 1 and your modulus 2. Well, here, if you're raising it to a power, those moduli will be the exact same thing. So you're going to take your modulus and you're going to raise it to that power. It's like multiplying times itself. And then instead of adding your angles together, well, all the angles are going to be the same. So you're going to do n theta. To where your angle is just going to be multiplied by how many there are, plus I sine of n theta. And that is how we're going to raise these things to powers. You simply, like on number 5, let me zoom in. This theorem says find the power expressed in rectangular form. So you're simply going to take the modulus out front, raise it to the power. And then you're going to take the cosine, you're going to take the argument here, and instead of doing pi over 3 plus pi over 3, and then you'd have to do it again and do it again, well, there's going to be 4 of them because you're raising it to the fourth power, so you can simply take your angle and multiply it by that power and do the exact same thing over here, and you pretty much have it. There you go. So you have 2 to the 4th power, which is 16. The cosine of 4 pi over 3, let's say that's 240 degrees. So that would be a third quadrant, 60-degree reference angle. All students take calculus, so that's going to be a negative for cosine and sine. So negative 4 pi over 3 against our reference angle is 60, so cosine of 60 is going to be a half, plus I times, now that is sine of 4 pi over 3 will also be negative, so let's go ahead and put our negative out front here. And the sine of 4 pi over 3 or the sine of 60 will be root 3 over 2. Distributive property now, 16 and 2 will cancel, leaves you with negative 8. 16 times a negative is going to be a negative, and the 16 and 2 will cancel and leaves you with an 8 and a 1, so that's going to be 8 root 3. And you can put the I out there just to make sure that you have it separated, or most people, again, will put the I in the middle right there. So negative 8 minus 8I root 3. Now think about what just happened. We could have changed this thing back into its standard form or its rectangular form right here. And here's what you would have got, 1 plus I root 3. Now we're raising this to the 4th power. Now if we wanted to raise this to the 4th power in this form, we would actually have had to FOIL this thing out. 1 plus I root 3 times 1 plus I root 3 and got an answer. And then done it again and multiplied those two answers together. That would have taken a little while. So this has really sped up the process here. And that's the whole purpose of it, especially a 6th power. That would take a while. Simply take your modulus, raise it to that power. And then you're going to take each angle and you're going to do the cosine of 6 times pi over 4. And 6 times pi over 4, when you reduce that, that would be 3 pi over 2. 3 pi over 2. And again, I simply multiplied by the angle by 6, and that's what you get. Now 3 pi over 2, that's 270 degrees, so that's a quadrantal angle. 4 to the 6th power, let's go ahead and clean this up. 4 to the 6th power is going to give you 4,096. The cosine of 270 is 0, plus the sine of 270 will be a negative, so you'll have a positive I times a negative, so let's go ahead and put a minus right here. The sine of 270 is negative 1, so that's going to be negative 1 times I. 0, you don't have to put the 0 there, and that'll be a negative, when you multiply it out, negative 4,096 I, which again is much faster than raising this thing to the 6th power. It says, note, you must write complex numbers in polar form to use de Moivre's theorem. So notice here that this is not in polar form, so we are going to have to change forms. So let's remind you real quick on how do we change forms. Well, first off, we need an R. Let me see. And R, your modulus is going to be the absolute value of this complex number. So to find your R, we're going to do the square root of a squared plus b squared, which would be 3 plus 1. So the square root of 4, which is 2. So there's your R value. And then you're going to have to do a theta. You're going to have to find a theta value. So let's go ahead and graph this thing. Root 3 is your real value, and negative 1 is your I value. So we're going to go right root 3 and down negative 1 is somewhere down in here. So we need an angle. We actually need this angle. Let's go ahead and again zoom in. This was a root 3 and this was a 1. In order to find that angle, we can simply use our tangent. The tangent of, well, let's find the tangent of our reference angle first. The tangent of my reference angle is opposite over adjacent. When you rationalize that, you actually get root 3 over 3. And it's like, okay, well, we know that. That's one of our common angles. The tangent of a 30-degree angle would be root 3 over 3 or pi over 6. However, we want this angle. Our reference is 30, but we want this one. If this is 30, then this must be 330. Or if we wanted in radians, that'd be pi over 6 and 11 pi over 6. Pi over 6 was our reference, and 11 pi over 6 is our theta. So therefore, let's go ahead and write that down, 11 pi over 6. And that would be a 4th quadrant angle. Now let's take these two values and let's write this thing in trig form. So trig form is simply R times cosine theta, which is 11 pi over 6, plus I sine theta, which again was 11 pi over 6. And there's your trig form. And close your parentheses. Now we want to raise this to the 8th power. So now that we have in trig form, now all we have to do is take your modulus, raise it to the 8th power, times the cosine of 11 pi over 6, and you multiply those by 8. So let's come over here to the side and do 8 times 11 pi over 6, and let's cross cancel that. That'd be a 4 and a 3, and that's going to be 44 pi over 3. And I really don't want to deal with that 44 pi over 3, man. That's a huge angle there. Let's look for we can use coterminal angles here. Let's take off some rotations. And I know that a rotation, I would subtract off multiples of 2 pi is a rotation. So that's going to be common denominator will be 6 pi over 3. And I can continue doing that over and over and over until I get a smaller angle that's much easier to work with. And I subtracted that rotation off multiple times, and it eventually ended up as 2 pi over 3, which is a much smaller angle to work with. So plus I sine of 2 pi over 3. And again, we just found a coterminal angle that was easier to work with. So now let's clean this up. 2 to the 8th power is 256 times the cosine, 2 pi over 3, that's 120 degrees. So 2 pi over 3 is over here in the second quadrant. 120 degrees has a reference angle of 60. So therefore, that's going to be a negative value. Let me go ahead and erase that. We have a negative. The cosine now, we can use our reference angle now that we know it's negative. The reference angle, cosine of 60 will be 1/2. The sine in the second quadrant will be a positive, so I'm going to leave this as positive. And the sine of 60 would be root 3 over 2. So now distributive property, 256 times negative 1/2 would be a negative 128. A positive, 256 and 2 cancels and leaves you with 128 root 3. So that's what you would get when you raise this to the 8th power. And again, that is much faster than actually going through the process of multiplying that times itself 8 times. Okay, let's do another one. Again, let's change this to trig form. First, I'll find your modulus by taking the absolute value. That'd be the square root of a squared plus b squared, which would be 1 plus 1. So that'd be root 2 would be our modulus. Our angle, we need to find out what quadrant we're in. -1, +1 is going to end up here. This would be, again, find your reference angle is the way I like to do it. This is a 1 and this is a 1. The tangent of my reference angle, you can call it whatever you want to because this is actually theta. The tangent of my reference angle will be 1, so that means my reference angle must be a 45-degree angle. So if this is a 45-degree angle, then this must be 135. And I'm just going to leave that in degrees because honestly, we're changing it back to degrees anyway. So let's go ahead and leave this in degrees and work entirely in degrees. So therefore, my complex number written in trig form is going to be r cosine theta plus I sine theta. And again, I want to raise this thing to the 5th power. So to do that, you're going to do the square root of 2 to the 5th power. And then you're going to take each of these angles, this 135, and you're going to multiply it times 5. And when you do that, let's say that'd be 675 degrees. However, we don't want to work with 675. That's an ugly angle. So let's take away a rotation to find a coterminal angle here, and we get a 315-degree angle. So this would be cosine 315 plus I sine 315. And now let's just clean it up. And let's start out by doing something with a square root of 2 to the 5th power. Now, a square root of 2 to the 4th power we can do. So I'm going to split this thing like this. Square root of 2 to the 4th power, root 2 times root 2 is 2. And then times itself again would be 4. So that would be 4 root 2. So you can raise a root to an even power but not an odd power. So you're going to have that extra one left over. And then the cosine of 315. 315 is in the 4th quadrant. Has a 45-degree reference angle. All students take calculus. So cosine will be positive. And the cosine of root 45 is root 2 over 2. The sine will be negative, so I'm going to go ahead and put a minus sign there. I times the sine of 45 is also root 2 over 2. So now when we distribute 4 root 2, 4 root 2 times root 2 will be 4 times 2 or 8 over 2. Minus I times same thing, 4 root 2 times root 2 will also be an 8 over 2. So that would be a 4 minus, let's go ahead and write this 4 first. 4 minus 4i is what you would get. Number 9, what happens when you raise this to the 6th power? Now, could you do this the old way and actually raise these out to the 6th power? Sure. But again, much easier using de Moivre's theorem. Your modulus is going to be the absolute value of this of this complex number. So let's do the square root of a squared plus b squared. When you square a negative, it becomes a positive. So that'll be a positive 2 and a positive 6. So you get root 8, which is going to clean up to 2 root 2. That's going to be your modulus. Your angle, let's sketch this out. You're in the third quadrant because both are negative. Let's draw our reference angle here. Let's see, this is a root 2 and this is a root 6. So therefore your angle, to find your reference angle, the tangent of your reference angle is going to be opposite over adjacent. It's root 6 over root 2. That would be a root 3 reference angle. So that means that angle alpha would be a 60-degree reference. So that means that this is 60. However, we're looking for this angle, which would be a 180 plus the 60. That's a 240-degree angle. So therefore, this turns into r times the cosine of theta plus I sine of theta. And we want to raise that to the 6th power. So the way we're going to do that is we're going to take 2 root 2, raise it to the 6th. We're going to take all of our angles and we're going to multiply them by 6. So that'd be the cosine of 1440 plus I sine of 1440. But again, we don't want to deal with 1440. Let's talk about what is its coterminal angle. So let's take away some rotations and continue doing that over and over and over. And you actually, if you continue subtracting 360 and subtract 360 again and doing it over and over and over, you actually get 0 degrees. The coterminal angle with 1440 will be 0. So you can replace both of these with 0 degrees. So 2 root 2 to the 6th power would be 2 to the 6th power times root 2 to the 6th. 2 to the 6th, that's 2, 4, 8, 16, 32, 64. Times the square root of 2 to the 6th will be 8. And here's another way you can do that. The square root of 2, that's the same thing as 2 to the 1/2 power. To raise that to the 6th power, you're going to multiply powers. That'd be 2 to the 3rd, which is the same thing as 8. 64 times 8 is 512. And then bring down the rest of the stuff. You have now cosine 0 plus I sine 0. The sine of 0 is 0. The cosine of 0 is 1. So you have 512 times 1, which is simply 512. So if you were to multiply this out times itself 6 times, you would simply get a real number of 512. Number 10. 4 plus 2i to the 4th power. Let's find our modulus to write this in trig form. The square root of 4 squared is 16 plus 2 squared is 4. That's going to be root 20, which will be 2 root 5. That's your r. Your angle, you're in the first quadrant, so we can actually just use our reference angle, go over 4 and up 2. Our angle's somewhere up in here. So this is a 4 and this is a 2. So therefore, to find my angle, and I can call it theta here, the tangent of my angle will be opposite over adjacent, which is a half. Now we've got to be careful here. That's not one of our common angles. So therefore, to figure out what this angle is, let's do the inverse tan. So theta will be the inverse tan of 1/2, and that's going to give me an angle of about 26.57 degrees. Now, you've got to be careful with that because if you want your answer to be more exact, you might have to round that thing to 3 or 4 decimals just to get it as exact as you possibly can get it. So let me go ahead and erase all this stuff. So now, here is my trig form. You have the modulus, which is 2 root 3, times cosine theta, which is 26.57, plus I sine of 26.57. So there is your trig form. We need to raise that to the 4th power. The way that we're going to do that is raise this to the 4th power. So 2 root 3 to the 4th. And then we're going to take our angles and multiply each of those by 4. So that'd be the cosine of 106.28 plus I sine of the exact same angle, 106.28. Now let's simply do 2 root 3 to the 4th power. That'll be 2 to the 4th power, which is 16. and root 3 to the 4th power, which is 9. And 16 times 9 would be 144. Cosine of 106.28 is about negative 0.28 plus the sine is about 0.96. Now, I made a mistake up here. Let's go back to this. I couldn't read my own writing. This is actually supposed to be 2 root 5. So when you square the 2, it does still give you 16. But when you square the root 5, that's root 5 times root 5, which is 5 times itself, which is 25. That should have actually been 400 right here. So go back and let's correct that. Now, when we distribute that, here's what we get. Negative 112 plus 384i, and that would be your final answer. Now, let's use that same idea. And now let's take some roots of complex numbers. For any positive integer n, the complex number z, which is still given as cosine theta plus I sine theta, has exactly n distinct nth roots. Now, let's remind you that what we're actually doing here is we're taking like square roots. A square root of x is the same thing as x to the 1/2 power. The cube root of x is the same thing as x to the 1/3 power. So we're still raising things 2 powers. We're actually still following the exact same steps as we are before. But here is the formula that we're going to be using. R to the 1/nth power, which looks very similar to what we just did. To raise z to a power, you simply raise first off r to the power. Now this is what's going to be a little bit different. Cosine of theta, which theta is again your argument there, but there's going to be repeat answers here, and that's what this is talking about. Over n. Now we're still doing we're multiplying this theta, this argument, times 1/n. We're still doing the same thing there, and doing the same thing with our sine as well, and that should be plus I times sine, to where again k is the whole number 0, 1, 2, 3. So what this is simply saying right here is we are going to have repeat answers. And I do this thing a little bit different. And let's see if this makes a little bit more sense than the formula itself. So first off, it says find all the nth roots. So the third roots we're looking for, and again, that's what it meant by up here. It's going to have exactly n distinct roots. Since we're looking for the cube root, and let's write it like you're used to seeing it. We're looking for the cube root of negative 2 plus 2i. That's all we're doing here. How many of these cube roots are we going to find? 3. It's the exact same thing as saying like the square root of 16. If we're talking about the positive and negative, if we're looking for a square root, how many square roots did that have? It had 2. It had a positive 4 and a negative 4 when we found the square root. So kind of the same thing here. So first off, what we need to do is we've got to write this negative 2 plus 2i as or in its polar form. So I'm going to go ahead and do that for you just to save us a step. And there's what you have. Now, again, I'm going to follow a little bit different set of rules here, just because it makes more sense to me. Okay, now how are we going to raise this right here to the cube root? Or how are we going to take the cube root? We raise it to the 1/3 power. So let's follow the exact same rules that we just did. Let's take our number out front, our 2 root 2. Let's raise it to the 1/3 power. Then let's take each of our angles and let's multiply it by that power. Multiply by 1/3 and you get 45 degrees plus I sine of 45 degrees. Okay, so before I do anything else, I want to take care of this 2 root 2 to the 1/3. And I want to show you a little trick here that actually works on this one. This is not always going to work, but this kind of comes out nice and neat. I'm going to write that 2 root 2 back as the square root of 8. The 2 root 2, that's the square root of 4 times square root of 2, which is square root of 8. And that's what I'm trying to raise to the 1/3 power. So, again, this is just a little trick because I noticed something about the 8 that triggered that I might be able to do that. So let's write both of these as exponential powers. That's 8 to the 1/2 to the 1/3 is what I'm doing. Flip-flop those. And that's legal because this is a power to a power. 8 to the 1/2 to the 1/3 is the same thing as 8 to the 1/3 to the 1/2. So, look at that. And the cube root of 8, 8 to the 1/3, is actually what you're doing there is actually 2. So this is now 2 to the 1/2, which is the square root of 2. But it just so happens that this turns out to be the square root of 2. And then you have cosine 45 plus I sine 45. Now, the rest of that stuff up here, what does all of this mean? Okay, here's my interpretation of it. This is one of my answers. I should have a total of 3 answers. Now, here's what's neat about these roots. They're equally spaced. I've got one root that occurs at a modulus of root 2 and at an angle of 45 degrees, which is somewhere right along in here. My other answers will be spaced out equally. Well, I know that from here around to here is a total of 360 degrees. And I know that if there is a total of 3 answers and all the way around is 360, I can take that 360 degrees and divide it by those 3 answers, and I should have an answer. I should have a root every 120 degrees. And that's all you need to know, is that if you're looking for a cube root, you'll have a cube root that occurs equally spaced from another cube root. So they're always the same angle measures from each other. So therefore, if my first one occurs at 45, well, guess where my second one occurs? It's going to be root 2 times the cosine of 165. Now, how did I find 165? I simply added that 120. They're equally spaced out. They're going to occur every 120 degrees. So this is where my second root is located. Where's my next root located? It will have the exact same modulus, but it'll have the cosine of 285. Now, where did I find 285? I simply added 120 again. They're equally spaced. So there's I should have 3 roots, but you might say, well, could you not just add 120 again? Well, what happens when you add 120 to 285? It gives you 405 degrees. Guess what 405 degrees is? It's coterminal with your original. So therefore, we found all 3 of our radicals, or all 3 of our cube roots. So let's go ahead and distribute these back out. That's going to be the square root of 2 times cosine of 45 is going to be root 2 over 2 plus I times root 2 over 2. When you multiply those out, root 2 over 2 times root 2 will give you 1 plus 1i. There's your first root. Do the same thing here, and you're going to get very similar answers. However, cosine of 165, it has the same reference angle, I believe. Well, maybe not. Hang on. It does not. It has a reference angle of 15 degrees. This one we don't know, so let's go ahead and clean this up. The cosine of 165 gives you negative 0.97 plus the sine of 165 gives you 0.26. So that'd be root 2 times negative 0.97 plus 0.26i, which is a final answer of negative 1.37 plus 0.37i. Do the exact same thing on the last one. Distribute times the cosine of 285. Again, 285 is not one of the angles that we know. It would have a reference angle of, let's see, 285 is 75 degrees from 360, so we don't know that, and we don't know the sine of 285 either. But use your calculator, multiply this out, and here's what you're going to get. 0.37 minus 1.37i, which is very similar to the last problem. However, if you were to graph these things, again, one of the answers that we've already looked at would be located right here. You would have another answer located, I believe it would be somewhere right in here at 165 degrees, which is actually going to be about right here. You have another answer located at 285, which is about right here. Again, the modulus would be the same for all 3 of these answers, but the spacing is what I want you to focus on. Those spacings between those 3 answers are identical, and we were finding a cube root there. Let's do another one. Now we're looking for a 4th root. We're looking for the 4th root of 4 root 3 plus 4i, which we can write as, again, that's 4 root 3 plus 4i to the 1/4 power. So to find that 1/4 power, first we're going to have to write this in trig form, and I'm going to go ahead and do that for you. So there's what you have. And again, we're going to raise this to the 1/4 power. So what does that mean? We're taking the 4th root. How many roots should we have? We should have 4 roots. So let's go ahead and find our first root, and that's going to be raise 8 to the 1/4 power, just as we have been doing, and take each of these angles and multiply them by 1/4. So that would be the cosine of, when you multiply, gives you 7.5 degrees, plus I times the sine of 7.5 degrees. However, we have 4 different routes, and where are those routes going to occur? Those one trip all the way around, okay, we're at 7.5 right now, which is somewhere right in here. All the way around trip would be a 360-degree trip. However, we know that we're going to have a route every 4 routes. So take and divide that by 4. We're going to have a route every 90 degrees. That's all you have to do there. So our next route's going to occur 90 degrees later. So it'll occur at 8 and 8 to the 1/4 power, same modulus, cosine of 97.5 plus I sine of 97.5. The next root will occur the same modulus, but another 90 degrees later. So cosine of 187.5 plus I sine of 187.5. And the last root, because there should be 4, should occur another 90 degrees down the road. So at the cosine of 277.5 plus I sine of 277.5. Now, if you do this correctly, if you were to add 90 again, you get 367.5, which is the exact same thing as 7.5. So from here on out, all you have to do is take each of these roots, distributive, and this is all calculator work, 8 to the 1/4 times the cosine of 7.5, and then times the sine of 7.5, and here is the 4 answers that you should get. And I do want to point out the symmetry that you see there. And we understand hopefully why we have the symmetry, because those answers are occurring every 90 degrees. So you will have the X and Y values will be very similar in those 4 points. Okay, number 13. I believe we got a couple more. Again, step number 1, we're going to write this in trigonometric form. We're raising it to the 1/3 power. We're taking the cube root, so we're going to raise it to the 1/3 power. So in trig form, here's what you have. The R value we found by taking the square root was 2 root 2, or excuse me, by taking the absolute value. And then your angle we found was 300 degrees. And we're going to find the cube root of that, so we're going to raise it to the 1/3 power. So to do that, we should have 3 different answers. We're going to have our first answer located at 2 root 2 to the 1/3 power. And you could actually use that same trick I did a while ago for that. I believe that's going to be simply root 2. Then you're going to take your angles and you're going to multiply it by 1/3. So that'd be the cosine of 100 plus I sine of 100. Since you have 3 roots, 360 is a full trip. So divide that by 3, you'll have an answer occurring every 120 degrees. So if this is my first answer, the second answer, and I'm going to go ahead, this 2 root 2 raised to the 1/3 power, I'm going to go ahead and write that as the square root of 2. That's what you're going to get. So the next answer will be located 120 degrees later, which will be the cosine of 220 plus I sine of 220. And then your last answer will be located at the cosine of 340. Just add 120 more to the angles, plus I sine 340. So there's your 3 answers. Distributive property, because we don't know the cosine or sine of 100 or 220 or 340, we will just have to type that into the calculator. And here are the answers that you will get. And you don't see near as much symmetry there because that was a 3rd root, so you're not going to have the symmetrical values that a 4th root did have. Okay, number 14, last one. And I'm going to go through all the steps on this one again, just to remind you. Step number 1 is the modulus. To find the modulus, you're going to do the absolute value. So that's going to be the square root of a squared plus b squared. So that would be the square root of a squared will be 2. Plus negative root 2 squared will also be 2. That's the square root of 4. So your modulus is 2. Your angle. Let's see, first off, what quadrant we're in. Negative puts me somewhere down here. This is root 2, and this is also root 2. So let's find our reference angle. And we can already see that since the opposite and adjacent, this is an isosceles triangle. So since that and that's the same, then that means these two are going to be the same. That's a 45, 45, 90 right triangle. So this reference angle is 45. So therefore my theta, since I'm in the 3rd quadrant, will be 225. So therefore I'm doing R cosine theta plus I sine theta. we're raising it. We're finding the fifth root, so we're going to raise it to the 1/5 power. So we're going to have, again, 5 different roots. So the way we're going to do that is going to be 2 to the 1/5 power times the cosine. We've got to take this 225 and multiply it by 1/5. When you do that, you actually get 45, which is one that we know now, plus I sine 45. Now, we're going to have roots now. Let's go ahead and figure out what the rest of our roots are. We should have a total of 5. And the way that we find out where they are located, we're going to take 360 degrees or 2 pi, full rotation. We're going to divide it by 5 because we're going to have 5. And that means that I'm going to have a root that occurs every 72 degrees. So my next one's going to occur 72 degrees later. So that'd be the cosine of 117, which I definitely don't know, plus I sine of 117. And you're just going to simply, again, to find the rest of them, keep adding that 72 degrees. And here is what you're going to get for the rest of them. And it turns out that the only one that we actually know is this cosine of sine of 45. So the rest of them are going to be ugly decimal answers. So let's just go ahead and type everything into our calculators. And here's going to be the 5 roots of this complex number. And you do see a little bit of symmetry on those answers, not a ton, but there are your 5 roots.